Welcome to EPG Pathshala lecture series for postgraduate architecture students. The topic we are looking into is sustainable and green building design, and the module within this sustainable materials is what we shall be discussing. So, within sustainable materials, we hope to study the differences between various materials suitable for different purposes like exterior, interior, etc., to help create awareness about the concept of embodied energy and its value in existing buildings, to learn how to segregate the different purposes of material on site based on usage, to understand how the material we choose for design affects the environment. So, if you actually look at the correlation between materiality and site, we have different components. We have the found site, that is, what site we have chosen to construct our site, to construct our building. Then we have horizontal, which is paving devices. Then we have walls and then roofs. So, this is like a graph that we have formulated, and we have to see within the found site what all is there. Is there a water body? What green mature trees are there? Shrubbery, grass, all of that has to be documented. Mature trees are recommended not to be cut unless the situation demands it, and if at all, now there are a lot of options of transplanting trees, or if that species is not suitable for transplantation, more number of trees have to be planted to make do or to compensate for the loss of one mature tree. Water bodies have to be taken into account. Grass, shrubbery also has to be taken into account to ensure that they are not indigenous species. If they are indigenous species, then they also have to be kept safely. Now, moving on to different kinds of paving in the site. It could be plain sand, pebbles, concrete, impervious concrete paving, pervious concrete paving. You could have irregular stone paving, and finally tarring. So, depending on the context of the site, the scale of the site, paving devices can be chosen. Road has to be there unless it is completely vehicular traffic and it's some campus we are designing. If it's residential, let's make it pervious, so there is some amount of maintenance that is reduced. At the same time, the water table can also be restored. So, then we have the stone paving, which is considered a very good option, where it is even useful for pedestrian friendly towns where cobbled pathways are very famous. Sand and pebble tones can be used as a part of landscaping. Moving on to walls. Now, walls again, you could have different types: brick, stone, wood, concrete, metal, or even corrugated sheets. Again, the walls also play an important role with respect to the kind of energy source that we are trying to create. What kind of passive cooling or passive heating are we trying to create? Where is the site? What kind of climatic zone is it? What kind of microclimate is there? All of these factors have to be studied. Then finally, if you look at roofs, what is there now with most sustainable roofs is having a green roof or a terraced roof. You have a shingle roof, concrete roof, pebbled roof, you have a metal roof, or you could have a good old tarred roof as well. Ceramic tiles can be used. It can have mangalore tiles, concrete. All of these are permutations, combinations of different types of sites, different types of materials that are used in different parts of the building construction at the site. So, how do microclimate and site materials relate? Microclimate is the mini climatic zone around your building as modified by local conditions. Things that naturally change your microclimate are amount of sun received over the day, wind and natural breezes, the natural materials of the site. Things that you select also change the microclimate. Material choices like paving, roofing, wall materials and planting, color of materials. In cold climates, you need to select materials to increase the heat in winter and decrease heat absorption in the summer. So, there is a very intrinsic relationship between site materials and microclimate, and how they can be achieved, and how the relationship has to be studied to ensure that we achieve a well-desired product. Solar axis and microclimate. The microclimates in the backyards on either side of the walkway are different as a result of solar axis, even though materially they are identical. You can see here, because the sun angle is coming here and this building comes into the shadow, this place gets in more heat than this side. This is the Bain Avenue Co-op in Toronto. So even though the materials for the roofing, walling, everything is identical, still the microclimate is different because of the sun angle. There are different microclimates on the front versus the back of the house due to materials, amount of shade and orientation of the sun. Now, this is the same property we have images of. This is the east elevation of the house and this is the west elevation, that is the front and the backyard. Now, if you look at the front of the house, it has more paving and less tree cover, which makes it hotter. But the back asphalt roof also raises the general heat level of the site. This is an asphalt roof that we saw in our siting conditions and the different materials that exist. So you can see how the paving and the lesser tree cover versus the backyard. The backyard actually is completely in shade, but still the roof in this condition ensures that the greater level of heat in the site. Now, what is the effect of found site natural materials? Now, if you look at the found site, what is there in the site existing before you even start constructing your building? So, natural materials and natural site landscape and configuration will affect the heating or cooling potential of the site. Replacing natural soft materials with hard or impervious materials will increase the heat retention potential of the site. So, natural materials, when any site that we find has a particular set of materials, the first choice is not to tamper with it unnaturally, because anything that is there available near the site, if it's reutilized, it is considered natural and the best option. But if we add on hard impervious materials, then obviously the microclimate of the site will change, because we are increasing the heat retention potential of the site. Now, if you look at pervious materials that are preferred, as they actually allow the rainwater to be naturally cleaned and cycled without being directed into the storm sanitary systems. So, pervious, now you have pervious concrete things, you have terracotta tiles, you have slate tiles, you have all sorts of outdoor options now that are in the pervious category, which are easy to maintain and even prevent waterlogging. Heat retention makes for a warm microclimate and can increase the cooling requirements of the building in the summer months. So, if you use impervious or even pervious materials like the pervious concrete that is there, but it will still increase the heat retention capacity of the building, and it will bring in heat into the building and it will consume more power eventually. What effect does roofing choices have? The choice of roofing material critically impacts heat retention, because roof is the main structure through which heat enters a building. Dark materials absorb heat, which is directed or redirected to the urban atmosphere, where greenhouse gases trap it in the place. Light materials reflect the heat, that is cool roofs. Green roofs stay cool, produce oxygen, absorb rainwater, reducing the pressure on the sewer system. So you can see that the green roof is most preferable, but there has to be taken care when constructing a green roof. It has to be done in a way that does not encourage water retention, does not encourage water crumbling, so that there will be dampness of patches or something seen inside the building. The quality of construction should be suitable to the method of the roofing choice we are choosing. Cool roofs theory. Cool roof materials have two important surface properties: a high solar reflectance or albedo and a high thermal emittance. So you have two important properties where you have solar reflectance, where, like you can see here, vernacular architecture on hot climates, the finished roofs are in light color, which will reflect the heat, as well as it will provide for a clear, clean surface for water collection because it's serrated or corrugated. So any dust that is there will settle and only the clearer water will come down. So number one, there should be a higher solar reflectance and it should emit high thermal emittance. Solar reflectance is the percentage of solar energy that is reflected by a surface. Thermal emittance is defined as the percentage of energy a material can radiate after it's absorbed. So looking at options of green roofs, here you have the Vancouver Public Library. Green roof technology started in Germany more than 30 years ago, and the credits for this concept of roof started there. Proprietary systems are being looked at with some seriousness in places like Canada. Green roofs reduce urban heat island effect and decrease carbon dioxide levels well within the city. So when something of this nature has come in nearly 3 decades back, it's only now that it's catching on in countries like India. We have very few examples of commercial buildings or institutional buildings that are even using green roof theory. Even the few establishments that do come up with green roofs are not completely green in a sense. They are planter boxes that are settled along the wall of the perimeter of the terrace, and they are more an aesthetic purpose than a truly green roof that is in place. So what exactly does a green roof do? They provide a much higher level of insulation, which of course is not in all cases. Green roof treatments can either cover all entire roof or just a smaller part depending on the requirements and the limitations of the project. A couple of examples, you have the Godrej office in Hyderabad, which was a successful model of applying the green roof theory. A part of the building, like we just discussed, not the entire project, but a part of the admin block was completely treated as a green roof theory, which was made accessible even to the employees, which they can use when they are on a break or they can even go there for a stroll. So incorporating elements like this within the design, which can be used for the leisure or the pleasure of the people utilizing the building, is the best option. Because any kind of roof that cannot be accessed or accessible makes it a redundant space or a space which can promote antisocial activities. So I think it's better if we have a green roof in such a way that is accessible to different parts of the people working in the building, living in the building, but at the same time it has to be secure, safe and well maintained. So a lot of these theories are slowly coming in now. You can even see a couple of residential commercial projects that are emerging within our city. You have one of the famous projects coming up now by Phoenix, which is part of the Phoenix Market City in Velachery. So you actually have a mall and a commercial establishment, and above that, in one portion of the mall, they have raised the building by about 5 to 10 floors, and they have a residential core. So for those residential people, the terrace of the mall proves to be the ground floor of their building. So it's a completely green roof, and if you actually come down to the ground floor of the apartment complex, it's like staying at a lawn level of any other ground floor apartment. We are already about 5 floors above the ground, and the terrace has been very clean and neatly modified into a green roof. So there are very few successful examples of green roof that are emerging in our country, but again, suitable to our climate, this would be one of the best examples to follow, because by having a green roof, we are reducing the amount of heat entering the building through the roof. At the same time, we are also reducing the concrete jungle and the urban heat island effect and increasing the level of oxygen in the city. Imagine the environmental benefit and resultant cooling if all these roofs you see in this building were either green roofs or cool roofs. It will completely remove the urban heat island effect. And both these options are not impossible to follow. Let it be a skyscraper, let it be any kind of a building, the cool roof as well as a green roof is completely feasible. And like we have discussed even initially, Such elements of roof design should not be left to choice anymore, but it should be the core responsibility of an architect to choose any element. Say we are constructing a building with X number of walls, Y number of windows. Let's take a pledge, or let's take a step to make sure that whatever walls that we construct will be passively designed. Let it be passive cooling or passive heating, but will be sustainable. The materials that we choose will be sustainable. The roofing materials that we choose will be sustainable. The methods of construction will be sustainable. So individual elements that we choose have to be delved and packaged in the right way of sustainable design for the end user to get its benefits, and in the longer run for even society to get its benefits. Moving on to the effect of paving choices. Now, if you look at the horizontal paving choices, paving or the displacement of pervious green surfaces with hard surfaces is the primary cause of negative changes to the local microclimate. So this is what most of us do as architects when we get into a site. Our sites are 90% of the time natural. But what we end up doing is, once we design the main purpose of a building to make maintenance easier, to ensure that there is no waterlogging around the building, we end up putting up impervious surfaces like this around the building and making sure that there is no water retention or water entering the water table in anywhere. And even the lawn and the landscaping is sporadically done in small clusters which do not have any correlation to the scale or site of the project. So such steps taken by architects completely mitigate the microclimate of the place. And when we are talking of the microclimate of 20 such buildings, the local climate also starts getting affected. So paving can not only cause heat retention and overheat the urban environment, but it can also impact water runoff and absorption into the site. Paving selection needs to simultaneously, number one, allow for water to be absorbed into the earth such that let it be pervious. It has to be durable for winter traffic conditions and snow removal. Create a cool microclimate to prevent the heat island effect. So every material that we choose to construct our building, and when we say building, I mean on the site, it has to have a responsibility towards creating a step towards a sustainable design. So paving choices usually by most architects are left as an afterthought. Even after the completion of the building, they would be like, okay, let's just pave it up. That should not be the case. Everything should be given importance and go hand in hand. The paving material could be a reflection of the facade material or the exterior material the building is going to use. The paving material should also have a correlation to the interior of the house and the concept on behind which the building has been constructed. So all of these have to have a correlation rather than an afterthought which has been decided at a much later date and just forced upon the site. So maximum our aim should be to increase the permeability of the paving surfaces. In the sense, we have to make sure that we are letting the rainwater go and enter the water table. We have to ensure that it also simultaneously helps movement of vehicles, helps prevents retention of water and snow, and also helps create a cooler microclimate and prevents and at least does not add on to the heat island effect. Now, if you look at this example over here, Phoenix, Arizona, this is a shopping center with a white roof and pavement. This is an example over here that you see. Here again, all of these are typical examples of cool roofs where this is a completely urban heat island effect. You can see the smallest percentage of greenery in this area. But of course, Phoenix, Arizona should be noted is a dry, arid climate with most of the time it's under drought conditions. So they cannot afford to have a green cover, because maintaining a green cover like a lawn is not recommended in such places because they consume a lot of water. In such cases, we have to come up with suitable indigenous species which are suitable to that climate, that will consume water suitable to that area. And you can see using a cool roof like this and a cool pavement like this helps mitigating the heat and reducing the heat island effect. Now coming on to permeable paving. Different materials are available that allow for a level of durability for traffic, yet also let the water drain through. This is what we see used in a lot of resorts, five-star hotels, where it is easy to maintain to a certain extent. It's very aesthetic, as well as it's an environmentally conscious decision to gain brownie points, especially when you're trying to get a certification. The main problem with using a completely impermeable surface is, number one, there are advantages, the only advantage being easy movement and low maintenance. But what actually happens is, if every building like this creates impervious paving, where will all the water go? That's when flooding actually occurs, because there'll be one building that's a little higher or lower, and those buildings will end up getting water from the surrounding areas. So it's very important that permeable paving is no longer treated as an option, but as an only solution, as a paving material which will help not only suitable to any kind of project of a smaller scale, but also larger scales like resorts, hotels, industrial complexes, factories, etc., where there's a huge footfall of vehicles as well as pedestrian movement. Now, if you look at issues of snow removal must be accounted for when choosing materials. Permeable concrete is also an option. In our scenario, if you look at it, we have to think about water clogging, water logging and all of that, because if it is going to be impermeable concrete, where will all the water go? It will end up having a sink at some point of time. At some point of place, there will be a sink in the geography of the site, and all the water will end up collecting there, creating a negative space. What are the effect of other material choices? We have discussed paving materials, we have discussed roof. The next important thing that we need to think about is walls. So walls, accessory structures will affect the overall tendency of the site to either retain a heat and create a very hot environment. The typical walls that you usually see are brick, stone, wood, concrete. Very rarely do you see metal or corrugated sheets. But again, depending on the purpose of the building, if it's going to be an industrial storage area, it could be metal. If it's going to be container placement area within a port or something, it could be corrugated sheets. But it depends. Again, most scenarios we are either going to be discussing concrete, brick or stone. And stone, again, with the context of an historic context, only stone is going to come in, or in a purposeful way when we are going to try to adapt stone as a new material choice. So all of these materials will help create a urban heat island effect, or if used correctly with permeable paving or with landscaping, can actually be used as a method of passive cooling or passive heating as the situation and site warrants it. So shading your walls will help to prevent heat gain. However, in very cold climates, when the sun angle is very low, material choice can be used to hold heat in the building and warm up the outside spaces. So this is what we are talking about, where glazing also comes into play over here, and glazing is also a very important material that has to be considered. Even though it's not a wall material, it's a part of the wall as a fenestration. So when the sun angle is low, it has to enter, the sun has to enter in maximum number of places, and the glazing helps us do this. And then the quality of the wall, let it be concrete or stone, will help to keep the walls warm for a longer period of time. So how is the material or the coefficient of the material, solar heat gain coefficient of the material, helpful in deciding whether it's going to be a passive cooling material or a passive heating suitable material? Now, if you look at the primary sources of sustainable materials, you have renewable sources or reuse from waste. If you think of renewable sources, it is basically wood, timber, it is all of those things that we usually have. Now, reuse from waste is also a very good option, because we are talking about materials which are being salvaged from other sites. It could be window shutters, it could be door shutters, it could be even concrete parts which can be used as landscaping elements like benches or like seating options and all of that, because concrete cannot be reused in the traditional sense of a concrete sunshade cannot be put as a concrete sunshade, but a concrete sunshade can be used as a bench in a park. So we have to try to reuse from waste. And scrap, again, let it be reinforcement rods. Reinforcement rods are again used as installation devices to create planter boxes, to create terrace roofs. All of these are elements that need to be reused from waste. So any building in the area that is demolished, if first of all, demolition should not be in a first choice that we are going for, because like we have discussed in this previous presentation about the concept of embodied energy, every material of construction has a particular energy value assigned to it. And when a building is demolished, so many megawatts or kilowatts of energy is gone down the drain. So that is equivalent to consumption. So even though we are not directly utilizing that amount of energy, we are destroying that amount of energy, which is equally bad. And again, we are going to require a huge amount of energy to replace the building we have demolished. Under certain circumstances, when demolition is unavoidable, we have to try to utilize every possible element from the building before creating it, deeming it ready for demolition. So you have renewable source is significantly of plant origin. It can be obtained from sources like solar energy, wind energy, wood, natural fibers, certain kinds of polymers, etc. as typical examples. Now, if you look at reuse from waste products as raw materials, typically products of recycled matter, materials that can be dismantled and reused again. Typical examples are plumbing, doors, crushed glass, concrete slabs, wood chips, etc. This is a new building material, typical sustainable building materials that have entered the market. Wool bricks, this is obtained by adding wool and certain kinds of natural polymers found in seaweed to the clay of the brick. So what happens by adding this is 37% more strength than burnt bricks. So if it is not going to be burnt, so the fuel efficiency increases and the consumption also decreases. It's resistant of cold as well as wet climate. They are dry hard and do not need to be fired. So if these bricks don't need to be fired, we are actually saving a lot of time as well as energy. And because they are suitable for varied types of climatology, it is also very good. Looking at sustainable concrete, concrete is a friend of the environment in all of its life stages, right from the raw material production to demolition. It is only the cement part of it, which is an important component agreed, that is not considered green. But what happens with cement is, cement can also be replaced by broken wood, by broken ceramic, by fly ash and other such materials too. So crushed glass, wooden chips can be added to make it sustainable, and this concrete also can be utilized in a sustainable manner. So sustainable concrete reduces CO2 emission of the building, and that's what adds to the sustainable nature of the material as well. Though concrete under normal circumstances might not be considered concrete, might not be considered sustainable. Concrete with sustainable nature has to undergo certain changes, though even though it does have occupy or consume a certain amount of energy from the energy cycle, it is still negligible as compared to the other materials. What are the merits and demerits of sustainable buildings? If you look at the typical merits, efficient technologies, easier maintenance, improved indoor air quality, energy efficient, energy water efficient, improved health, water conservation. So when we are talking about an building being energy as well as water efficient, it's very important. Improved health of the user is a very important factor which cannot be quantified, because health of an individual is not subjective. It cannot be quantified and said it has 100% usage or 100% utility or 80% usage. Water conservation is very important. Utilization of efficient technologies is again a very important point. Easier maintenance can go either ways, because in some cases sustainable buildings do require more maintenance initially, because the people, the users who are using sustainable buildings have to be educated about it. If there is a certain component, a sustainability component about the building, it has to be made aware to the users before being made open to everyone. Now, if you look at the demerits, demerits is initial cost is very high, availability of materials is not that easy, it needs definitely more time for construction, and it needs more skilled labor. So, if you talk of initial costs being high, every demerit has a merit in the background. Initial cost is high, but the return on investment is much, much higher. When you're talking about investing an initial amount, which is say 20 times more than a normal building, your maintenance, every year maintenance that you spend on keeping a building clean, air conditioned, well maintained, all of that will be much lesser in a well designed sustainable building rather than an ordinary building. Again, availability of materials and skilled labor go hand in hand, because we are talking about being a sustainable building by procuring materials around a particular radius. That does limit us to a certain extent. Also, if we have to be truly sustainable and we have to get material from elsewhere, we have to justify how truly sustainable are we. Next important component is how much more time do we require for construction, because when we are, again, time cannot be quantified. Time is money in most cases, and especially in the field of construction, it means more money to labor, more labor intensive costs, and even keeping yourself open to prices if escalation of prices of materials. So you're going to jack up the prices for a number of other factors. It's going to affect the quality of work as well as the quality of the final product. And even the amount of labor that is required could be different, and the quality of the labor. Now, if I'm going to have a passively designed building or a sustainably designed building, I need to have skilled labor who will understand the language I'm talking. So, besides architects being aware of sustainability, it's even the lower cadre of construction workers who have to be made aware of the concept of sustainable design, as well as the merits and demerits of it in the long run. Because once they are taught how to build a sustainable building, then we can come to the next stage of how to maintain a sustainable building and how to utilize a sustainable building. That brings us to the end of this lecture. Thank you.